Wow, it's Friday. How are you doing? It is the 28th. Today's objective is to be able to draw covalent structures again, and I'm going to add a few details and things to you here as we go. The formal idea today is what are isomers? And our definition of what isomers are is this. They are compounds with the same formula, but a different structure. So in other words, there might be two possible ways to draw something correctly. Because they have different structures, an isomer will generally have different properties, sometimes subtly different, sometimes very different. Isomers may be very similar or they might be actually very, very different. Now, I'm going to show you some pictures here. This is called cis dichloroethine, and these here, these black are carbon, the red ones are oxygen, and the white ones here are hydrogen. And we're going to see this in a couple examples here. So this is called cis. This is there's a second molecule that's like this, and it will be an isomer. By the way, notice that there's a double bond here in the center. So this is the cis version. This is the trans version. Now, if I go back and forth, you see cis, which usually means same. The oxygens are on the same side. Trans meaning across, the oxygens are on different sides, and they are different from each other. So here is a formula, C2H6O, and I'm going to show you two different structures of it. First of all, I want to add up the number of valence electrons. I have not been beating that into you guys, and I usually do, and I need you to do this now. Most of you are kind of natural with it and really good at it, but some of you not so much. Okay, so I've got two carbons, so it's 2 times 4 valence electrons plus 6 times 1 valence electrons plus the oxygen here, which has 6. That gets me to 8. 8 and 6 is 14, so this will be 20 electrons. So my final structure has to have 20 electrons in it. And the carbons and the oxygen must have an octet. I can't make this work unless they have an octet. So the first thing I'm going to do is chain together the carbons. And then I'm going to add the oxygen to it and a hydrogen like this. Now, I have 6 hydrogens, so I'm going to put 1, 2, 3, 4, 5, and then the sixth one is there. I have 20 electrons, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now, everybody has an octet. No one exceeds the octet, and we have made a stable structure here, and this is actually called ethanol. Now I'm going to make it slightly differently. I'm going to take this oxygen and I'm going to put it in the middle between the two carbons. Now I'm going to take the 6 hydrogens and bond them around to the carbons. This is going to give the carbons a stable octet. Now I have 16 electrons right now, so 17, 18, 19, and 20. This is a different structure. These are very different from each other, and so they are called isomers of each other. They are isomers. Same formula, different structure. Here I have one of them, and this is the first one that I drew. It has the oxygen and the hydrogen on the end. I'll try and hold it like this. And because of that, the two carbons are in a chain. Here is the other one, which I have drawn, where the carbons are on either end and the oxygen is in the middle. This one is actually a gas, and this one is actually a liquid. They are isomers. They are very, very different from each other. I'm just going to add that down. This is a gas. It's actually probably an anesthetic. This is a liquid. All right. Now, I'm going to show you one other here, C7H7Cl. I'm sorry, C3H7Cl. So again, 3 times 4 for the carbons, plus 7 times 1 for the hydrogens, and 7 on the chlorine. So 3 times 4 is about 12, plus 7 is 19, so 26 electrons total on this structure. Whenever we have multiple carbons, we kind of want to chain them together. Carbons do tend to chain together. And then I'm simply going to put this chlorine on the last one, Cl. Now, I'm going to fill up the octets of my carbons. If I have enough hydrogens here, I won't need to double bond. If I don't, there could be a double bond. All right, that worked, and everything is stable. Everybody has an octet, and then I'm just going to put the last 6 electrons to get to 26 right there. Okay, that's looking good. So what I have made here now, and I'll make it really quick for you, is this. Ah, okay. So here is our structure. And one thing I want you to notice is this. If I take this chlorine right now, let me get a different color. Yeah. No, come back. We'll go with green. If I take this chlorine, I can't just stick it on this carbon over here because that is this just reversed. So there's really only a couple ways that I can write this. I can move the chlorine, and I'm going to draw the isomer now. I'm going to move it to the central carbon. So I'm going to put the 3 carbons together. Now I'm going to move the chlorine to here. I'm going to attach my 7 hydrogens. And I'm going to put the last 6 electrons to get to 26 like that. So these are the 2 isomers here. These are the 2 isomers. And then I'm just going to show you, here I'm going to go to a different color. If I simply have the chlorine on this side, it's the same thing but in reverse. So you have to think 3-dimensionally. So these 2 here, let's just throw up a different color. These 2 here are isomers. These 2 here are actually the same. And then, of course, these 2 here would be isomers because the other 2 are the same. So you can't just flip it around. You have to change the location of something, and that is the crucial part of it here. Okay, that's what isomers are, and I've asked you to draw a few. Now, don't do that. What I'd like to do now is this. The one thing I'm going to ask is, please don't draw, and I'm just going to, sorry to take all your time. Let me just erase some space up here. I just want to save you some time here and some heartache. And what do I mean by that? Well, that's fine. Didn't really want that. That'll work. Okay. You, obey my commands. All right. No, maybe. All right. All I really wanted to say was this. Don't draw tiny triangles. So say you have a car. Come on. All right. Well, it isn't working. Maybe if I go away, view. You're like right there at your desk going, he's an idiot. He's an idiot. Okay, there we are. Now, clank. Don't draw tiny triangles. This doesn't really work. Don't do that. Why not these tiny triangles? Some of you try to do it with the carbonate structure that I gave you, and you were drawing these things. And the reality is things are too close together, and it creates too much repulsion in them. So no tiny triangles, and don't do it. And a matter of fact, I really haven't done anything cyclic with you or that makes a circle yet, and I'm not sure that we even will. So there you go. That is the end of the video. I hope this helps. Take a look at what I've asked you to do over the weekend. Next week, I think, will be pretty much our last time together. I'm looking forward to it with you. Over and out. Have a great weekend. Goodbye.